Assalamualaikum dan selamat sejahtera. Kita continue untuk soalan 2C, which is calculate the pH of the solution at the equivalent point. As usual, step number 1, you have to calculate the volume of titration that added to achieve equivalent point. As we know, at equivalent point, the mole of acid is equal with the mole of the base. But for this time, the acid you use is acetic acid. Okay. We want to find the volume of titrate added to the analyte. That means volume base. So you have to use the formula MAVA over MBVB, A over B. When you use this formula, you have write the equation acetic acid with an AOH to produce the salt and H2O. Based on this, the stoichiometry for acid and base is similar, 1:1. So just insert the value molarity acid 0.2, 25 for acetic acid, 0.2 for molarity base, and volume base that you want to find, 1/1. Thus, volume base is equals to 25 mils. So volume titration here refer to the volume NaOH is 25 mil that you added to the analyte to reach equivalent point. Step 2, as usual, you have to find the mole in conical flask, and you added mole in conical flask, which is acetic acid, using MV over 1000, which is 0.2 multiplied by 25 over 1000, and you will get 5 exponent negative 3. How about mole NaOH, MV over 1000, 0.2 molarity. The volume you added to reach equivalent is also 25 over 1000, and you will get 5 exponent negative 3. This is the mole in conical flask, and this is the mole that you added from burette to achieve equivalent point. Okay, after you get the mole here, you have to do ICF table. When I say ICF table, you have to starting with the equation between NaOH and ethanoic acid. Okay, as usual, all the species in aqueous phase except your H2O. You must use the single arrow because this is a neutralization reaction. Okay, your unit for ICF is mole. So mole inertia for NaOH is come from part 2 here, step number 2 here, which is 5 exponent negative 3, and the mole as a ethanoic acid here is for inertial ethanoic acid, 5 exponent negative 3. Okay, not produce yet your salt. Okay, this is liquid not involved in your ICF table. For row change, you have to choose which one the limiting reactant between these two reactants. But for this case, the value of acid and base is similar, so we just write that value. Don't forget the sign. For reactant negative, but product is increased. And the final mole is I minus C. That means 5 minus 5 will become 0 here. And 5 minus 5 will become 0 here. And also is increased 0 plus 5 for product I plus C become 5 exponent negative 3. Okay, you have to edit one row after you draw the ICF table, which is referred to the molarity, mole per volume total. Volume total here refer to volume acetic acid in conical flask added with volume NaOH that you added at equivalent point. So, since the mole of NaOH is 0, molarity also 0. Same goes untuk ethanoic acid. But for CH3CONA, you have the mole here, you have to find the molarity. Volume CH3COH in conical flask is 25 plus volume titration you added to the analyte is also 25, and then you convert into liter and you get 0.1. After you settle the ICF table, okay, you have to analyze only molarity the salt is remain in the conical flask. That means in the conical flask you only have the salt solution with the H2O. So for this case, how you want to find the pH of the salt? So you have to use subtopic salt hydrolysis. Still remember salt hydrolysis? Okay. As usual, if you want to find the pH of the salt, you have to starting with the dissociation of the salt. The salt here refer to the sodium ethanoate, CH3COONA solid, H2O, produce its ion. Okay, as we know, cation is always from base, while anion is come from the acid. So choose one suitable base that produce ion Na plus. I will choose NaOH. And choose one suitable acid that produce CH3COO minus. I will choose CH3COOH, ethanoic acid. Then classify the strength of the acid here. This is weak acid, organic acid. How about NaOH? This is strong base. So from this case, when we have strong base, that means we conclude this ion Na plus cannot ionize in water. How about CH3COH? Since it is a weak acid, we conclude that CH3COO minus can ionize in water. Since you said can ionize, you have to prove. So CH3COO minus can ionize, that means react with H2O to produce, okay, the phase is aqueous, this is liquid. Okay, this CH3COH is a weak acid. That means this ion is conjugate base. Kalau base, that means dia adalah proton acceptor. So it become CH3COOH. Right? How about H2O? Since it's a proton acceptor, this is proton donor. So become, donate 1 H, become OH minus. Okay. From this equation, since it produce OH minus, so that this salt, okay, CH3COONA, is a basic salt with pH greater than 7. So that means at equivalent point, okay, only the salt remain in the conical flask. This salt is a basic salt. This basic salt is dissolved in water to produce basic solution. When we check the pH of this basic solution, the pH must be greater than 7. Here we don't know the exact value for pH, but we just predict the pH either greater than 7 or less than 7 at this equivalent point. Okay, so this is the answer, pH at equivalent point. Okay, we continue with soalan number 2D. Calculate pH after, okay, addition of 30 ml NaOH. Okay, as I said before, when you said the total 30 ml, that means this is a final volume of, okay, total means final volume of titrant, that added to the analyte. Okay, so at this point, after the addition 30 ml, that means you don't need to find the volume of titrant, which is NaOH. It already stated here, volume is 30 ml. Okay, we just to proceed step number 2, calculate mole acetic acid. MV over 1000, 20, 0.2. Okay, 0.2 multiplied by 25 over 1000 here, and you will get 5 exponent negative 3. How about mole NaOH? Molarity multiplied by volume you added, okay, at 30 ml, that means volume base 30 ml over 1000, and you will get 6 exponent negative 3. This is mole acetic acid in conical flask. This is the mole that added from burette after addition 30 ml. Okay, next step, as usual, you have to do ICF table. You starting with the equation, neutralization in the conical flask, which is NaOH added to the analyte CH3COH to produce the salt and water. The initial change and final row must in unit mole. Alright, so you just substitute the mole acetic acid in your initial row, 5 exponent negative 3, and the mole of NaOH added, which is 6 exponent negative 3. Okay, the salt does not produce yet. H2O not involved in ICF table. As usual, you have to choose between these two limiting reactant. Okay, between these two reactant, which one is limiting reactant? Choose the smallest number between 6 and 5. You write 5 exponent negative 3 here. Okay, also for your salt here. As usual, your reactant is negative because decrease the molarity, the mole, and also the product is positive. Next, your final untuk reactant I minus C become 1 exponent negative 3. Your acetic acid 5 minus 5, that means totally consumed because your CH3COH is limiting reactant, and your product increase by 5 exponent negative 3. After ICF table, please add one row below about molarity, which is N over volume total. Volume total here refer to volume acetic acid plus volume added. Okay. Now molarity for NOH divide by volume acetic 25 plus 30. Alright. Convert into liter and you get the molarity here is 0.01818. Your molarity for CH3COH is 0 because no more mole present in the conical flask. How about your salt? Over 25 plus 30, convert into liter and you get 0.1. Okay. After you find the molarity, you have to clarify. Okay. Identify. At the end of the reaction neutralization, remaining in the conical flask is molarity, the salt, and the molarity NaOH, which is strong base. So when this mixture in the conical flask, okay, so remaining in the conical flask is the salt and the strong base. Is it buffer solution? No, because it added strong base here. So since you have strong base and the salt, as usual, dominant in the conical flask is strong base. Dominant, that means the pH of the conical flask adalah dikuasai oleh strong base. So seolah-olah pH the salt adalah minor sahaja. So macam mana kita nak cari pH strong base? Yes, you have to use if table. So if you want to use if table, you have to starting with equation for strong base. NaOH, okay, completely dissociate will become its ion. All the phase is aqueous, right? Initial, final. The unit is molarity. The molarity sodium hydroxide is 0.01818, not produced yet. At the final, no more concentration for NOH because completely dissociate. This will become 0.01818, also 0.01818. So di sini concentration OH minus is 0.01818. Thus POH equals to negative log 0.01818. You will get 1.74. You want to find pH, so 40 minus POH will become 40 minus 1.74. You will get 12.26. This is the pH after you added 30 ml titrant to the analyte. Okay, now you want to sketch titration curve, right? So as usual, before you sketch, you have to tabulate the data in the table. You have to tabulate the pH that you obtained from the previous question. Okay, pH of analyte and the volume of titrant. Okay, remember this pH refer to pH analyte and this volume always refer to volume titrant added. Okay, tabulate in table. Okay, for the first question for part A, before added NaOH, that means volume will become 0.00, 2 decimal places because come from the burette reading. The pH is 2.72. After you added, okay, at half equivalent point, the volume you added is 12.50, the pH will become 4.74. At equivalent point, you added 25.00, the pH is greater than 7. And the final titration, you added 30 ml. The pH will become 12.26. This is for question part A, question part B, question part C, and question part D here. You have tabulate data in table first. You get the marks. And then your y-axis is referred to the pH. And your x-axis refer to the volume titrant in ml. Okay, don't forget your unit here. Okay, next, before added. Okay, before added, the pH is 0.00. Okay, anggaran adalah di sini ada 2.72. The first point here. Then 12.50 here become 4.74. The second point here, 25.00 greater than 7. Okay, 7 here. And 30 ml become 12.26. Okay, here, remember this is a type 3, which is strong base weak acid. You have to remember the pH range for this type. Okay, pH range is 7 to 10. pH range for equivalent points occur. Alright. Okay, so this pH range also refer to the steep part. If you want to sketch the graph, steep part, that means graph yang hampir menegak. So you cari dulu di mana 7 dan 10. Okay, so di sini steep partnya adalah pada 7 dan 10. This is steep part. Okay, and then you continue touch the point. You continue touch the point. This is your steep part, refer to pH range 7 to 10.